Okay, for example 2, the data in the table below were collected on 5 successive Saturdays. They show the average number of cars entering a shopping center parking lot. The value of T is the number of minutes after 9 a.m. The value of N is the number of cars that entered the parking lot in the 10 minutes prior to the value of T. So let me just make sure that we understand what's going on here. T is 20, so 20 minutes past 9 a.m., so we're at 9:20, right? This is how many cars entered the parking lot between 9:10 and 9:20. And this is 9:40, that's how many cars entered between 9:30 and 9:40. That's 10 o'clock between 9:50 and 10 o'clock. So that's what it's giving us. So as we're getting closer to 10, we can see the numbers getting bigger, right? More people waking up, some people slept in a little bit. So we have our early risers, maybe some people got caught in traffic, but they're there now, and now a lot of people are going. And notice the numbers growing increasingly large through, that's 10:20, 10:40, 11, 11:20. So 11:10 to 11:20 is the most people enter the parking lot then, right? And then it starts decreasing at that point and going on from there. So that's what it's telling us, and that's the data it's giving us. So again, job 1 is to enter the data in our calculator. And again, I've already got a problem entered in here, right? So I want to clear out everything I've got in here. I'm going to clear out my table. And I'm going to go to y equals. I'm going to clear out my equation. I'm going to keep plot 1 turned on because I'm going to want to do a scatter plot, so that's fine. I'm going to go to my stat, and I want to do clear list. Because again, if I go to edit right now, you see the lists are both entered with stuff, right? So I go to stat, I choose clear list, just hit number 4, and I want to clear list L1, stat 4, L2. So L1 and L2 are both cleared out. All right, so now if I go back to my stat edit, both my lists should be empty. Empty is what I'm starting with every time. The most common mistake people make in these problems is they do that delete thing instead of the clear list thing. And there's some data up here that you can't see. Like the list is there, but it's like starting lower, and you still got numbers up there that are affecting your answers. So make sure that your lists are clear to start off with. My T is just going up by 20, so I'm just make sure 20, 40, 60, all the way up to 240. Alright, if I want to verify, I just really type those in without looking this time. So this time, another way of verifying is just to go through after you typed it in. If it's in a pattern like that, just type it all in and then just go back sure and make sure everything got typed in properly. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, already saw 240. So all my data is good for L1. L2 is more sporadic, so I'm going to make sure for each number 70 typed in correctly, 135 correct, 178 correct, 210, correct, 260, correct, 280, correct, 301, 298, 284, 286, 260, and 195. Okay, checked each number individually as typed in. I've got 12 numbers in both lists, so both my lists are the same number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers in my data fields there. So everything's typed in correctly. This time if I, again, did a scatter plot, if I hit graph right now, I've still got my stuff set for the other thing, right? So I can't see it. My window's not right. So I'm going to my window. I can see that T lives between 0 and 240. So 0, 240, let's go by 20, so that's what they went by. As far as y is concerned, the smallest y is 70, the biggest one's 301, so maybe from 0 to 310. I always like 0 to be there, just something I like. So, I mean, if you want to go from 60 to 310, I go a little bit lower, a little bit higher, so that they're not very bottom, very top. I like to be in the middle. All right. Maybe I'll go up by 20s on that also. Hit graph, and my scatter plot should be there. And looking at it, it looks to be somewhat quadratic, right? It's got that upside down parabola, right? All right. So the fact that it looks like a parabola, sort of, it's got like a little, somebody like hit it with a hammer or something here, but for the most part it's got that nice smooth parabola shape to it. Again, data collection is not about being precise, it's about, it looks kind of like this thing, it's going to fit pretty closely to this thing, and we're going to go with that shape. So quadratic regression looks to be the best bet here. So I'm going to go to my stat menu, and I don't think there's a coefficient in here for quadratic regression, if I remember right. The ones I had last year definitely didn't have it. Yeah, I don't see anything for a correlation coefficient. So you're just going to have to believe it's a quadratic regression. So if I go to my quadratic regression number 5, and again my lists are L1 and L2 every time, I want to choose calculate, hit enter, and it should give me an A, B, and C for a quadratic structure that's going to create a parabola that looks like what we have. So what we can see here is my quadratic equation is of the form ax squared plus bx plus c, where a is equal to this, b is equal to this, c is equal to that. The variables I'm using are n and t, so I want to use variables that are meaningful to this extent of this problem. So I'm going to use n is equal to negative 0.0125 t squared plus 3.9044 t minus 7.25. Unless you get a nice pretty number like 7.25, go for decimal places on these every time. All right. Again, this represents my quadratic equation that's supposed to be what resembles this data. If I wanted to verify that fact with my calculator, go to y equals, enter this as my function, using x's instead of t's because that's what my calculator understands. Negative 0.0125 x squared plus 3.9044 x minus 7.25. Okay, I don't have to readjust the window at all because I've already got my window set for the data. The graph's supposed to fit the data, which we can see there's my parabola, and it really closely fits that data. I'm not going to do a linear regression on this one, but if I tried, the line would probably go something like this through here. It would fit the data as best it could, but it's a quadratic set of data there, so it should be a quadratic regression. If we did a correlation coefficient, let's just, for the sake of that, let me just do that. If I did my linear regression t-test, just to give you an idea of, I don't want to do a line. Notice it gives me an equation, it gives me an A and a B value that makes a line that fits the data the best it can. But look at your correlation, there's 64.76% fit. Okay, that means that's some major errors in there. So that would tell you that, hey, that's probably not a good fit. Quadratic, yeah, you don't have a correlation coefficient, so you just have to let your eyes see. But again, if you get something in the 65% range for a correlation, that's bad. Okay, it always gives you R squared and R. R is the square root of R squared, obviously. R is the number you care about. R is going to be that amount of error in there. Closer it is to 0, the less likely it is to be right. Okay, so 65% is not good. Between 90 and 100 is a pretty good fit. So just keep that in mind. So quadratic regression, I'm simply looking for the answer. For linear regression, I want the answer along with the correlation coefficient. And every one of these problems has the possibility of saying, you know, what will the expected number of cars at this time be? All right, so let's see, this is 9, 10, wait, 10, 11, 12, 1, right? So they said how many cars should we expect at 2 o'clock, which would be another 60 minutes after that, right? So that would be t equals 300. If I just go over here and let t equal 300, we should expect approximately 39 cars to enter in 10 minutes between 1 and 2. And if we did 360, now it's negative 221 cars. So at some point it fails, okay? Because you can't have negative 221 cars. But for as long as that number is positive, it should be a pretty good estimate of how many cars are entering the parking lot. So keep that in mind. Again, that's what it's for. And data collection is out there all over the world. Your civil engineers go out and do it. They collect the data. They look at the model that the data looks like. They make a regression curve for it, and then use that to predict future outcomes.